Hi guys, welcome back to another video. I'm Nero from Cognicore AI, and today we will be testing the newly released Z Image Turbo Fun Controlnet Union 2.1 models, and I will be sharing a super fast download script to download the models on RunPod. In our last video, we tested the Z Image Turbo Fun Controlnet Union model, and since then, the Alibaba PAI team launched the 2.0 version of this Controlnet Union. But it had some typos, due to which the training was bugged and results were not optimal. So they fixed that and released this 2.1 version, which we are testing today. So what models are included in the 2.1 version? First, we have the Controlnet Union 2.1 8-step model, which is an 8-step distilled version of the Controlnet Union 2.1 model. Then we have the Controlnet Union 2.1 Tile 8-step model. This model was trained on high-resolution images up to 2048 by 2048 and was also distilled for 8 steps. Then we have the Controlnet Union 2.1 model. So this model was trained with corrected typos from version 2.0, and similar to version 2.0, this model also lost its acceleration capabilities. So this model needs more steps. That's why we have these 8-step distilled models here. Here we have some examples. Here is an example for 8-step inference on the Controlnet Union 2.1 8-step model and the Controlnet Union 2.1 model. As you can see here, the 8-step distilled model produces a much better image at 8 steps compared to the non-distilled model, but we will see which one is better in our testing. Then the most significant update in this Controlnet is inpainting. Yes, you can now inpaint using this Controlnet. Here they have shared an example where they used the pose and inpaint Controlnet together. Then we have some more examples of pose, canny, and depth Controlnet here. And here we have an example of image upscaling. We will test it and see how good it is. So if we take a look at the model files here, we have the tile model, 2.0 model, 2.1 8-step model, and the 2.1 model. All these models are 6 GB plus. Now let's head over to RunPod and start testing this model. I will get an RTX 3090 with 100 GB storage and deploy it. I will quickly install comfyui now. If you want an automatic install script to install comfyui on RunPod, watch the video in the I button. Comfyui is now up and running. Now to download the Z Image Turbo model, its text encoder, and its VAE, I will use the super fast download script I shared in my last video. The models are now downloaded and placed in comfyui models folder. Now to download these Controlnet models, I will use the Hugging Face download upload notebook I shared in my old video. I will link that video in the I button. Watch it to understand how to use this notebook. I will run the first cell. This is not a gated model, so we don't need our Hugging Face token, and we can download these model files without running the second cell. For people who have used this notebook before, I would like to mention that I have fixed the second cell, and you should not get any errors when you run this now. So to demonstrate, I will run this cell and add my token. Now you will see this text highlighted in red. Don't worry, it's not an error. You can ignore it, just make sure you see authentication successful message at the end. Now coming back to downloading the model files, I will go to the download specific file cell and run it. It asks for the repo name from which we want to download the models. So I will copy the repo name from here and paste it and press enter. Then it asks for the path of the local directory where you want to save these model files. So these Controlnet files have to be placed in the model patches folder. So I will copy the path of that folder and paste it here with a / in the beginning and press enter. Then it asks for the names of the files that we want to download. We can specify multiple files at once separated by a comma. So I will copy the file names of all 3 Controlnet Union 2.1 models and paste them here separated by a comma and press enter. Now it starts downloading the model files. You can ignore these. This is not an error. Wait for the model files to download. The model files are downloaded, and you can see the confirmation message here, and you can see the files are placed in the model patches folder. Let's also place the VAE in the VAE folder, QN34B in the text encoders folder, and Z Image Turbo in the diffusion models folder. Now let's open comfyui and start testing this Controlnet model. I have created a workflow to test all the different types of control nets under this 2.1 version. You can find this workflow in the video description. When you drag this workflow into comfyui, you might see this nodes missing warning. So go to the manager, click on Install Missing Custom Nodes, and install the custom nodes that appear. It's the Controlnet aux and RG3 custom nodes. Once the installation is done, click on Restart and Confirm, and then click on Confirm to refresh the browser page for the changes to take effect. Now the node's missing warning is gone. Now we can take a close look at the workflow. Here we have the Load Image section. Then we have the Model Loading section. Then we have the Prompt section, and then the Sampling section and the Generated Image section. And below these sections, we have separate sections for each Controlnet type. We've got sections for Pose, Canny, Tile Upscale, Depth, InPaint, and finally InPaint Plus Pose. Now I will upload an image here, which we will use for all these Controlnet types. So here is our image. Then I will press R to update node definitions and make sure that the correct models are selected here. Then I will enter the prompt here. This is our prompt. Then I will leave everything in the sampling section at default for now. First, we will test the Pose Controlnet. So I will unbypass the Pose section nodes here. I will select the Controlnet Union 2.1 model here in the model patch loader. Here we are using the recently added Z Image Fun Controlnet node instead of the Quen DiffSense Studio node we used in our testing of the old Controlnet model in our last video. This node adds the InPaint image and mask input options, which are needed to use the InPaint feature of this Controlnet 2.1 model. So now I will connect the model output from this node to the model input of KSampler and change the number of steps to 30 and run it. I changed the number of steps to 30 because we are using the non-distilled Controlnet 2.1 model first, and as we discussed, it needs more steps. Here is our image, and it looks great. It captured the pose perfectly from our reference image. Now I will change the number of steps to 8 and change the model in the model patch loader to the 8-step distilled version of the Controlnet 2.1. I will also change the seed in the KSampler to the seed of the image we just generated and make it fixed so that we can test the distilled and non-distilled version of the Controlnet 2.1, and I will run it now. And here's our image. And as you can see, there are a lot of artifacts in the image, and it's very blurry. And if we compare it with the image from the 30-step non-distilled model, you can see the difference is quite substantial. Now let's test the Canny Controlnet. Here as well, we will test the non-distilled version first. And we'll connect the model output from the Z Image Fun Controlnet node to the model input of the KSampler, change the number of steps to 30, and randomize the seed and run it again. Here is our image, and you can see there are some artifacts here, but overall the image looks good. The artifacts are there because it's trying to mold into the Canny map from the reference image. Now let's test the distilled version. I will change the number of steps to 8 and put in the seed from the image we just created and make it fixed and run it now. Here is our image, and we get even more artifacts here, and it's blurry as well. You can see the difference between the non-distilled 30-step model and the distilled 8-step model. Now let's test the depth Controlnet. And here as well, we will test the non-distilled version first, and we will leave the values in these nodes at default. And connect the model output to model input, and change the number of steps to 30 and randomize the seed and run it. And here is our image, and it looks fabulous. Perfectly captured the elements from the depth map. Now let's test the 8-step distilled version. Here is our image, and as with the last two Controlnets, we get heavy artifacts and blur here as well. Here's a comparison between the distilled and non-distilled version. Now we will test the in-paint ControlNet. Here we have the RG3 image compare node and the Z image fun ControlNet node, with the in-paint image connected to the image we have loaded here, and the mask as well connected to the loaded image. I will connect the model output to model input and open the mask editor and draw a mask on this woman. We will try to replace this woman with another woman. Then I will change the prompt to a prompt for a woman that we want to be painted in place of this woman. I will increase the number of steps to 30 as we are using the non-distilled version first and run it. And here is our image, and it replaced the woman nicely. If we see the image compare node under the in-paint section, you can clearly see that it only changed the masked region and everything else remains the same. By the way, these images take 1 minute 28 seconds to generate at 30 steps and a 1080 by 1440 resolution on a 3090. Now let's test the 8-step distilled model. Here is our image, and this as well has heavy artifacts and blur, as all the previous images from this model. And here's the difference between the two. Now we will test the tile upscale ControlNet. For this, we need to use the 2.1 tile 8-step model. Here we are using the image scale to max dimension node, and here I have set the largest size to 2048, because earlier, as we saw here, this model was trained on a max resolution of 2048 by 2048. We have it connected to the load image node, and then we have the VAE encode node here, and the tile node from the ControlNet aux node pack, giving the image input to the Z image fun ControlNet node. Leave the values here to default, and connect the model output to model input, and the latent from the VAE encode node to the latent image input of the K-sampler, and bypass the empty SD3 latent image node. Randomize the seed, and since this is an 8-step distilled model, we will use 8 steps only. I will remove this prompt from here. If you want, you can use a detailed description of the image as a prompt, but I will go without a prompt. And run it. Here is our image, and it looks a bit different as compared to the original image. If we take a look at the image compare node, we can clearly see it changed the image a lot. You can try decreasing the denoise strength in the K-sampler, but I would recommend using Seed VR2 for upscale instead. Now let's try this post plus in-paint combination. We have the model patch loader node, the Z image fun ControlNet node, a load image node, a preview image node, and the AIO aux preprocessor node. The aux preprocessor node is for post ControlNet, and it takes the image input from this load image node, and the image output from this preprocessor node is connected to the image input of the Z image ControlNet node. And then the in-paint image input of the Z image ControlNet node is connected to the main load image node up here, and the mask input as well. Now I will connect the model output to model input and unbypass the empty SD3 late node and connect it to the K-sampler. I will load the image that we want to use as a pose reference here, so we will be using this image as the pose reference. I will edit the mask on this image to be suitable for in-painting a woman standing in that pose. I have selected the non-distilled model here, so I will increase the number of steps to 30. Then we also need to change the prompt here, so we'll change it to this prompt for a different looking woman and run it. So here is our image, and it perfectly captured the pose from our reference image, and clothes and woman's look from the prompt, and the rest of the image looks unchanged as well. Great job! While I was editing this video, the Alibaba PAI team updated the ControlNet 2.1 models, so let's have a quick look at them as well. These are the 4 models they launched. First, we have a 2601 version of the 8-step model, trained with multiple resolutions ranging from 5112 to 1536 and more varied masks, and they focused on solving the blur and artifacts we were getting with the old 8-step model. Then we have the 2601 version of the Tile 8-step model, trained on higher resolution than the older version. They didn't mention the exact resolution. They also focused on solving the artifacts issue here as well. Then we have a light version of the 2601 8-step model. So this was trained similarly to the 2601 8-step model, but they used fewer layers, and this one is only 2 gigabytes in size, which makes it a good option for lower spec machines. Then we have a light version of the Tile 2601 8-step model. This one was trained the same way as the Tile 2601 8-step model, using fewer layers, also 2 gigabyte in size, and to be a good option for lower spec machines. They also shared some examples. Here we have an example comparing the old 8-step model versus the new 8-step model. If we take a look at the model file sizes, the 2601 version is still 6 gigabytes plus, and the light version is 2 gigabytes. Now let's test these new models. We'll use the same workflow. We don't have to change anything here. I'll use the same reference image and prompts so we can truly compare the results with the older models. I've downloaded all 4 models. Now I'll quickly generate images with each of them using all the Controlnet types. First, we'll test the pose Controlnet. Here is the image from the new 8-step model. As you can see, we don't have any artifacts or blur, and the image looks quite good. Here is the image from the light version of the new 8-step model. As you can see, it didn't capture the pose at all. Now let's test the canny Controlnet. Here's the image from the new 8-step model. As you can see, no artifacts or blur here either. Looking good. Here is our image from the light version of the new 8-step model. This one looks good as well. Now let's test the depth Controlnet. Here is the new 8-step model image, and it's looking good. Here is the image from the light version, looking good as well. Now let's test the in-paint Controlnet. Here is the image from the new 8-step model, looking good. Image from the light version looking good as well. Now let's test the tile Controlnet. Here's the image from the new version of Tile 8-step model. This is using 1D noise, and as you can see, it changed the image too much. So now let's try denoise of 0.5. Here is the image, and it mostly preserved the original image. Now the image from the light version of the Tile 8-step model. This one also used 0.5 denoise, and this one looks much better than the non-light version. Now let's test the in-paint plus pose Controlnet. For this as well, I'll use the same prompt and image we used earlier. Here is the image from the new 8-step model, and it captured the pose perfectly. Now the image from the light version, this one as well worked well. To determine which model is best, I prepared these grids for each Controlnet type. So let's have a look. This one is for Kenny. This is the reference image and the Kenny map. Below we have outputs from each model. First we have the 30-step non-distilled model. Then we have the old 8-step model. Then we have the new 8-step model. Then we have the light version of the new 8-step model. As you can see, the 30-step image looks good. The old 8-step image looks the worst with all the artifacts and blur. The new 8-step image looks very similar in quality to the 30-step image. And then the light model image looks good too. I think the new 8-step model is the best choice. It gives the same or even better quality results at only 8 steps as compared to the 30-step model. And if you have a lower spec machine, you can use the new light model. It works good as well. This is the grid for depth Controlnet. Here as well, you can see the new models look pretty good. This one is for in-paint Controlnet. Here we have the reference image and the masked image. And here as well, you can see the new models look good for 8 steps. Now the InPaint plus Pose Controlnet grid. Here we have the masked image, pose reference image, and the pose outline. Here you can see the mask artifact is present in all these images. Maybe it was a bad seed because I didn't get this in our testing earlier. But nonetheless, the new models hold up here as well, and the non-light version has the least mask artifacts out of all these in this case. Now the Pose Controlnet grid. Here the new 8-step model looks great, but the light version didn't follow the pose at all. Maybe a bad seed or needs higher strength. Then here is the grid for the tile Controlnet. All these were generated using 0.5 denoise strength. The light model looks the best here. As you can see, the grass is much more defined. The statue in the background is also better refined, and same with the water. You can find these grids in the video description if you want to take a closer look yourself. So this concludes our testing of the Z-Image Turbo Fun Controlnet Union 2.1 models and the new 2601 versions of the Controlnet 2.1 models. The new 8-step models are a great improvement over the old 8-step 2.1 models. And the speed at which the Alibaba PAI team is updating them shows their dedication towards the open source ecosystem, and I really appreciate that. As you have seen, the new 2601 8-step model works great and produces the images of the same quality and accuracy as the 30-step model with just 8 steps, which makes it the perfect choice. However, if you have a low-spec machine, you can also use the new light models, which are comparable to the new 2601 models. Once again, you can find this workflow in the description. If you want to support this channel, please use the link in the description to sign up for RunPod and use that account as your main account. You will get a random bonus credit of $500 to $500. So this is all for this video. I hope you guys found it helpful. If you did, please like the video, subscribe to the channel for more such videos, and automatic installer scripts for RunPod. Share your thoughts and comments. This is Nero, and I will see you in the next one.